Welcome to the Diet Doctor Podcast with Dr. Brett Scher. Today I'm joined by Professor Ben Bikman, who's a PhD and Associate Professor of Physiology and Developmental Biology at BYU. Now, Dr. Bikman got his PhD in bioenergetics, and he did a postdoc fellowship at Duke University in Singapore, specifically in metabolic disorders. He also works for company Insulin IQ, and he is a scientist. He is a true scientist at heart, and I think you'll appreciate that in this discussion. It does get fairly technical at times, I have to admit, because he does like to talk about the science and the specifics. But importantly, we try and bring it back to how the science can apply to us as individuals in our everyday life. And you know when Professor Bikman says something, you know it's based on research, you know it's based in science. And interestingly, he came to the low-carb world through science, whereas most people come to it through a personal experience, a personal connection, and then start to learn about the science. He sort of came the other way, and I think that makes him fairly unique, but also fascinating. So I love talking with Ben. I love having scientific discussions with him. And for you, I hope you get a lot out of this from science, but I hope you can take away some practical implications of what the science means, and also a sense of Ben as a human being and how he lives his life by the tenets of keeping insulin low, and how he helps to kind of educate his family about that as well, but without crossing any lines, without being too overbearing with it. And it plays in with his students as well, and we talk a little bit about that. So a lot of topics, a lot of science, but I think you're going to enjoy this interview. If you want to get the whole transcripts, please go to dietdoctor.com. It may be particularly useful for this one as we talk about some of the science and some of the big terms. And then, of course, all the other wealth of information online at dietdoctor.com. So enjoy this interview with Professor Ben Bikman. Professor Ben Bikman, thank you so much for joining me on the Diet Doctor Podcast.
Dr. Brett Scher, delighted to be here.
We're
Thank you.
so formal. Okay, we got the formality out of the way. Now let's just cut to the more casual discussion
Perfect.
here. Yeah, so we are here sort of in your backyard. We're at Salt Lake City. You're associate professor at BYU.
That's right.
And you run a lab there really focused on metabolic diseases. So tell us a little bit about your path, how you got into this personally and as a career path, the focus on metabolism and how that brought you to low carb.
Yeah, right. So we are in my backyard. BYU is about 30 miles south of here in Provo. And my lab at BYU is the Metabolism Research Lab. And that has been an unexpected journey, but one I'm so grateful for, sort of stumbling into this area. My undergraduate and master's degree focused on exercise science. And I was interested in the way fat cells, my master's thesis looked at how fat cells are linked to inflammation. And that was right on the tail of work coming out of Harvard in the early 90s, finding that adipocytes, fat cells, secrete pro-inflammatory proteins, cytokines. That to me was mind-blowing, the idea that the adipose tissue is an endocrine organ.
Right, it's not just a fat storage,
right,
it's actually active.
And that was the first I'd ever heard of that sort of situation. By that time I'd taken a graduate course in endocrinology, so I was familiar with the kind of stereotypical or prototypical glands, the thyroid gland, the gonads, the pituitary, the adrenal glands, these glands that existed in large part to secrete hormones that would have some systemic effect. That study, I think it was in 94, finding that adipose itself can secrete hormones, well, proteins, which are hormones in some instances, that opened up a whole new area of interest for me. And that, to me, it started my interest in insulin resistance. So anyway, I'm being too long-winded, but learning that adipose tissue could secrete pro-inflammatory cytokines and that obesity associated or induced inflammation then could cause insulin resistance. Mm-hmm. That started my interest in obesity and insulin resistance, looking at it in that paradigm, obesity causing insulin resistance. And then, so I did my PhD work with the wonderful scientist at East Carolina University. His name is Linus Dome. And we looked at how insulin sensitivity changed so rapidly in people post-gastric bypass. Right. So it's kind of this disconnection in metabolic status. They're still morbidly obese, of course, 1 week after post-bypass surgery, and yet they had become very, very insulin sensitive quite quickly. Mind you, I still think it's actually not much more than just you basically starve the person for a week and look what happens. But nevertheless, I then followed that up with my postdoctoral work at Duke, Singapore. That was more lipid-induced insulin resistance. So my world was and still is insulin resistance, and is specifically making a research agenda that is focusing on the pathogenic side of insulin. We talk about insulin like it's almost like a drug.
Yeah.
You need insulin, here's your syringe. And yet there's a downside, of course, to hyperinsulinemia, or when insulin's getting too high for too long. That, over about 5 years ago, at this point, started kind of moving into looking at ketones as independent signaling molecules, just molecules in their own right, not metabolic garbage.
Yeah. So I want to get into all the specifics.
Yeah. Anyway,
I want to get into all these. So how did that
got
translate to you personally, though? So I'm curious. So that was sort of your academic journey into it, and then when did you start to internalize this personally and say, "Hey, there's something to this. I want to start living this way."
Right. Yeah. That was probably about 5 years ago, or maybe even a little more. About the time I started teaching my undergraduate assignment at BYU, I teach pathophysiology, and I'd wanted to devote, so the sick body, by this time the students have looked over the physiology, the organs, how the organs work within the body as a system. Now all these nursing and the pre-med kids come to me, they take pathophysiology and looking at how things are working when they're not working. And I had a whole discussion focused on insulin resistance. And that, looking at that point, me forcing myself to say, okay, what is the best way to address insulin resistance? The classic, I'm a member of the American Diabetes Association, of course. The rigmarole is, whole grains, low fat, high starch, pretty high starch. And when I thought, okay, I'm not going to rely on any textbook. I just want this to be a course that is based on primary literature. That's when things started to fall apart. So I guess that's about 8 years ago. And then it was maybe a year or so after that when I really appreciated the randomized clinical trials looking at low carb versus low fat. And I thought, boy, this is all wrong. I'd always been healthy, and I'd always elicited enough self-control in just to stay lean and healthy. Mm-hmm. But once I really started losing my hair, mind you, a while ago, unfortunately, I really thought to myself, just from my ego's point of view, I can be bald or I can be fat. I can't be both. And I knew I had to convince a girl to marry me, and I thought, geez, if I can just at least control how lean and fit I am, then hair be damned. But anyway, so that became personal then.
Yeah, you got there from an academic side, and
very much.
It has to be sort of disconcerting to say, look, this is what all the textbooks say, this is what the guidelines say, but as an academic, I want to see the primary research, and the primary research wasn't there to support those
it was
claims.
An uncomfortable adjustment because I now was challenging what I had been taught and told by people to this day that I greatly respect and admire as academics, if not necessarily scientists in certain instances, and that is, of course, a difference. Mm-hmm. A professor versus a scientist. But anyway, it was an uncomfortable growth, but it was not my personal, experience in experiencing this incredible burst of health. I was already healthy. I was very active, eating generally pretty well, even though in the wrong kind of direction, but still, like I said, manifesting enough self-control to avoid junk food, which already put me in some pretty comfortable territory. For me, my transformation was almost exclusively academic. Yeah. It was, which again, as an academic, it made that transition both more uncomfortable because I thought I knew what I knew, but also gave me much more conviction because once I'd seen what I considered the reality, I couldn't unsee it. I could appreciate those p-values for what they were. That statistical significance carried a great impact when I really found it.
Yeah. Do you get pushback from other members of your department or at different society meetings or whatever, that since you're going against the grain, although still based in science, do you get some conflict or some pushback from colleagues?
I sure do. Not from my department. thankfully. And that's partly because my department has enough respect for me that they'll know, even when if they haven't overtly agreed with me, they can at least nod their head and say, yeah, but I don't doubt that Ben knows what he's talking about.
Right.
But there are others, and in fact, it's frustrating for me to remember, there are others across campus in different departments who have been very upset with my perspective and have made life a little difficult. But for me, it has always been, here are the data. Show me where I'm wrong.
Right.
If you're, one of the big points of contention was saturated fat should be no more than 10% of total calories. My sincere plea, here are a handful of clinical studies that put people on saturated fat, diets that were up to, in one study, 50% of all calories coming from saturated fat, one actual randomized clinical study. And here's a couple other ones. Please prove me wrong. And in all sincerity, please show me the study that number, that the dietary guidelines are based on, that saturated fat should be no more than 10% of calories. Please show me.
Where is that study?
Otherwise, leave me alone.
Right. And there's no response to that because that study does not exist. And that's where, big part of my message is the strength of the claim has to be backed by the strength of the evidence. And that's a case where it does not exist. And you can say it's been a human experiment without going through the IRB to tell everybody to do a 10% saturated fat because that we don't have that study.
It has.
So frustrating.
Yep. Now, when I've been able to actually sit down with some of these people who've disagreed with me, I think not almost, without exception, it ends up being an amicable, friendly conversation, and there can at least be a sentiment of let's agree to disagree,
right?
Which I'm okay with. I really am. But when it is someone who claims to know what I think without ever actually talking, that's I don't have any tolerance for that kind of silliness.
Right, that makes sense. But there's a lot of that out there, isn't there?
Sure is.
Twitter and social media and all over the place. People who just want to promote their belief, dig in their heels to defend their religion, so to speak, without really having an open mind to look at the other side and look at the literature. And that can be frustrating, I'm sure, for you.
Oh, no doubt.
Yeah. Okay. Well, one of the things you talk about are the plagues of prosperity.
Right.
Yeah. I think maybe you coined that term. It's a great
term.
Well,
if I did, I stole it from Gary Taubes,
who
had an article.
Okay.
Who had an article that he called "Prosperity's Plague."
So
not to be, Gary is far more eloquent than me, but I thought I can say that better, and so I said the plagues of prosperity because, in fact, Gary was, I think, talking about diabetes and insulin resistance more tangentially, and to me. It really was all the modern day diseases to varying degrees have a connection. They have a common core. If it wasn't directly causing it, it was making it worse. And of course, that was insulin resistance.
Yeah. So tell us about insulin resistance, because it's a term that gets thrown around a lot, and I've talked about before on this podcast that can be confusing for some people because insulin resistance. The cells are resistant to the effects of insulin, so insulin rises, so there's hyperinsulinemia.
Yep.
But there are also forms of insulin resistance with low insulin levels. So what's a good way for the average person to think about insulin resistance and how it impacts their health?
Yeah, so in fact, the way you described it initially is how I overwhelmingly look at the disease. It is a disease of as much a disease, at least when we think about the general systemic consequences, what it's doing to the body, it is as much a disease as insulin isn't signaling very well, so the resistance part of it, versus hyperinsulinemia. You drive more insulin. And in fact, I'm curious, you just mentioned there are instances when insulin's low and insulin resistance. I actually will very collegially disagree. To me, there are instances of what we call, I've heard it within the low-carb community, and I don't want to get us off on a tangent, so you pull us back if we need to. People will sometimes say you adopt a low-carb diet and you develop physiological insulin resistance, and I actually don't agree with that. There are instances in human physiology of physiological insulin resistance, and that's the 2 Ps as I teach it, puberty and pregnancy. But sure enough, hyperinsulinemia, at least relative to what the person should be, and that's always a qualifier, right? If someone is normally going to be at 4 units, microunits, and then they're at 10. 10 could be, in fact, pretty reasonable for someone else. But nevertheless, to me, insulin resistance goes hand in hand with hyperinsulinemia. And what we see in the instance of a low-carb adapted, a fat-adapted individual who takes a glucose load, and now their glucose tolerance appears to be worse. In fact, I call that glucose intolerance, which is not the same as insulin resistance. And we're splitting hairs, but I actually still think it's important because, at least to me, I don't know. I'm not comfortable citing or invoking the term insulin resistance if insulin is low, because if we were to give that person a bolus of insulin, that's going to work.
Oh, good point.
You see what I mean?
I see what
So if we were to infuse and do an insulin infusion, boy, that glucose there's going to be a response to that insulin.
Right.
And that's not the same as challenging the system with glucose, which I submit the system has become somewhat intolerant to, at least exogenous glucose.
So just the fact that the pancreas isn't responding by increasing the insulin output for that glucose load means it's glucose unresponsive, not that the cells are resistant to insulin. That's a very good point.
Right. But I can't say that I fully have my head wrapped around it, but I don't personally invoke the term physiological insulin resistance to describe the glucose intolerance that accompanies fat adaptation. Right. To me, they are different, but I think it's important.
Okay. And that's the scientist in you wanting to get to the...
But admitting that I don't know it all. More of the scientist in me.
Right. So since we're talking about insulin, there's this balance between insulin and glucagon.
Yeah.
So insulin, the hormone that basically says, we want to store fat. We want to take all the glucose, and appropriate it where it needs to go. And it's a marker that things are good, that we're in a fed state,
perfect.
From a, evolutionary standpoint. And glucagon being sort of the counterbalance, the opposite of that. And so one of the things that I've heard you talk about before is this ratio of insulin to glucagon ratio, especially how it relates to protein, because protein somehow has become very controversial in the low carb world. That protein can trigger gluconeogenesis, the new production of glucose. So if we have too much protein, we can get ourselves into trouble on a low carb diet. It's sort of a simple way to think about it, and the science of it is much more complicated and paints a different picture. So that's a long lead up to give you a runway here to go with, because I'm curious how you want to explain this.
Yeah, so the talk that I gave a year or so ago was the first time I'd mentioned the insulin to glucagon ratio, and it was in the context of protein, because as I had started, I was still just a few months having stepped into the so-called low-carb community. I had just gotten involved in Twitter, for example, and then just social media in general. Up until that point, literally 3 years ago or so, I had no involvement whatsoever. I was studying insulin and even ketones a little bit in my lab and totally oblivious to this whole world. I had heard the sentiment, hearing people adopting low-carb diets and their obsession with drinking oil, literally drinking oil. People that were getting hundreds and hundreds, if not over 1,000 calories per day in oils added to their drinks. And I thought, that is not healthy. And hearing this fear of protein, that kind of brought me back to a concept that I'd kicked around and thought about years prior, the insulin to glucagon ratio. You said it perfectly, and George Cahill was this old researcher from decades ago who really looked at starvation and a lot of insulin. He has a study called Physiology of Insulin in Man, or this big, beautiful review paper. It's so well done, to a quality of writing, et cetera, that you just don't really find. And I can say that as a guy who's writing and trying to copy George Cahill in a way. But he mentioned insulin as the hormone, the fed hormone, like you said, the hormone indicative of the fed state, but also the hormone that generally directs metabolism. And what I mean by that is it directs the use of energy. Like you mentioned a moment ago, is energy going to be stored or used, or as I had introduced a couple years ago, or wasted? And that's, of course, ketones. But nevertheless, the insulin to glucagon ratio does give an overall reflection of, is the body in a fed or a fasted state? The higher that ratio is getting, the more it is indicative of a fed state. In other words, store and inhibit so-called wasteful processes like autophagy, for example. And that's just the low-hanging fruit when you talk about the opposite of the fed state, which is fasted. Fasted state is a low insulin to glucagon ratio, and the most obvious form or effect of a fasted state is autophagy is enhanced. And so when I was thinking about how to structure a conversation about protein, I thought, well, let's look and see what happens in the insulin to glucagon ratio. And there was some delightful studies. It was kind of an amalgamation of studies, but largely based on the work of Roger Unger from UT Southwestern. And he's a glucagon guy, a legend in glucagon research. And I found an old study from him which looked at the insulin to glucagon ratio and how the low-carb insulin to glucagon ratio was almost identical to the fasted state and several points lower than the conventional Western diet. So it was pretty interesting to me, this idea of what I like to call a nutritional fast rather than a caloric fast. So someone who's still eating and getting energy, and yet their body is still behaving as if it's in a fasted state. There's mobilization of fat, there's activation of autophagy, even though they're not, in fact, hungry. They're not fasting. So anyway, finding ultimately that protein, someone could eat protein, and if someone was in a state of glucose excess, like getting the protein at the same time as glucose, or underlying hyperglycemia, that exaggerated this insulin to glucagon ratio. In other words, insulin really spiked. In contrast, if you're eating the protein in a fasted state or a low-carb state, because those two, in fact, are quite similar, then there was essentially no effect from the protein. And so I was eager to share that message. When I learned it, I was enthusiastic about it as well. But I have been delighted that insulin and glucagon, the kind of yang to the yin, have become kind of part of the vernacular in the low-carb realm, because glucagon is relevant. I maintain that insulin is the hormone that has two hands firmly gripped on the steering wheel of directing energy, but glucagon's got a hand there. But it is interesting to note the difference. Some people will eat protein and will, in fact, have massive glucose spiking effect. And it could be that as someone becomes a type 2 diabetic, their alpha cells, the glucagon-producing alpha cells, have become insulin resistant. That is, in fact, more work from Roger Unker, the glucagon scientist at UT Southwestern. They found that part of what I like to say flips the switch from insulin resistance, which is hyperinsulinemia, but normal glycemia, what flips the switch to go from hyperinsulinemia to hyperglycemia, or overt or frank type 2 diabetes, part of that is that the alpha cells become resistant to insulin's ability to inhibit glucagon production.
Right.
So they become insulin resistant. And that might be part of why the very insulin resistant type 2 diabetic, or just in other words, a certain amount of the population, will in fact find that as they adopt more carnivore or more protein heavy version of a low carb ketogenic diet, they might have some struggles with their glucose. They might have some struggles with insulin. Right.
If they're already insulin resistant to
begin
with.
Yeah, even to the point, especially to the point of diagnosed hyperglycememia.
Yeah. So, we're talking a lot about glucagon here, and that's probably unfamiliar for a lot of people because it's not a blood test we do, or that your doctors
commonly
do.
No.
So is it more of a research tool, would you say? And why isn't it being used clinically, do you think?
So you can get it measured, although I'm not the physician, but I know physicians who, they do get it done, and there are general reference ranges, but it is a separate beast entirely for reasons that I confess I don't know, something about the biochemistry of the molecule itself. It requires a totally separate vial of blood. I know when we do what's called multiplex assays, we can measure, or a multi-analyte, we could measure insulin, leptin, cortisol, growth hormone, all in one little batch of plasma from blood. Glucagon?
Oh,
It's an entirely separate test. It has its own set of chemicals that have to be added in order to isolate it, and then in order to quantify it. And again, I don't know the reasons, but it's its own beast.
Yeah, so I'd imagine it's something, I actually haven't looked into this, I have to admit, so it's probably something that not many labs do. It's going to be a send-out lab. It's going to be expensive.
Insurance definitely wouldn't pay for it.
Right, right. But I think it would be helpful for some people to know, what is my insulin to glucagon ratio, and will that affect the amount of protein I can handle? So short of having that test, what are some other markers people can use to try and help them determine if they can handle a certain amount of protein without worrying about gluconeogenesis, without worrying about their insulin to glucagon ratios?
Yeah, that's Brett, I don't know. There's not, I will say, if we can look at the insulin to glucagon ratio and maintaining it at a low state as itself partly reflected by the insulin resistance state, then oddly enough, the triglyceride to HDL ratio is a remarkably accurate predictor of who has insulin resistance. And then, but again, we're making some connections here. Then perhaps we could take that one step further to say it's probably a person who's going to have an insulin to glucagon ratio that isn't favorable. Now, one last comment about glucagon, as people are getting introduced to that perhaps for the first time, there is a phenomenon, I almost hate to bring this up, called glucagon resistance. And that could be instances of when people have had liver damage, like hepatitis, like an actual infection. And in those instances, those are the very small group of people who, and I emphasize this, it is a small group of people who genuinely have this, but that's when someone who might start fasting and things get very bad for them.
Oh, interesting.
Because in that instance of glucagon resistance, glucagon's main action is to mobilize fuel. It wants to mobilize fats from fat cells. It wants to mobilize the glucose that's been stored as glycogen in the liver, and it wants to tell the liver to make ketones, so it activates ketogenesis. In that fasted state, the inability of glucagon to break down glycogen in the liver and to promote ketogenesis in the liver, because the liver is glucagon resistant, makes for a brain that starts to suffer from fuel deficiencies. And so I learned of this from a person who claimed they would try to fast, and they were healthy. And sometimes many people are so addicted to eating that they can't fast without it being very uncomfortable. That is not what I'm talking about at all. But this person, healthy, lean individual, they'd fast and things really got bad for them. Profound headaches, extreme discomfort. They were able to find a physician who did a glucagon tolerance test. And this is documented in the literature, where they inject a small dose of glucagon, and then the expected effect is to see an increase in glucose, because glucagon will mobilize the glycogen from the liver. And this person didn't have it.
Yeah.
So a failure to respond to the exogenous glucagon confirmed this glucagon resistance.
Interesting.
And it exists. That is a real phenomenon, but albeit very rare.
Yeah. Well, that's clearly the scientist in you. I see how you get excited about that.
Yeah. I was thrilled to learn something new, frankly.
Yeah, that's great. So wouldn't apply to most people fasting, but for some people who do have trouble fasting, that could certainly be an issue.
It could be. And again, there would have to be, I think, some history of a liver, like an overt liver problem, cirrhosis, hepatitis, et cetera.
Yeah, alcohol or fatty liver, or All right. Now, you mentioned autophagy a few times in the description of the insulin-glucagon ratio. And so autophagy is a term we hear a lot about lately, a recent Nobel Prize.
Right.
So give us a quick summary of what autophagy is, but more importantly, what are the thresholds for triggering it? Because I think it's such a controversial topic now. Do we have to fast for 5 days to trigger autophagy? Is an 18-6 fast good for autophagy, or is just low carb good for autophagy? And how do we know? So to give us a little rundown on autophagy.
Yeah, right. Yeah. So as a general introduction, autophagy is a process whereby the cell, I'm going to use this term, and I hate to say it, but it kind of stays young. And what I mean by that, what's happening, the cell is able to almost check its inventory and know that the pieces within the cell, what we call organelles, the mitochondria, the endoplasmic reticula, the lysosome, the peroxisome, any parts of the cell inside of it, the cell can do an inventory and recycle those. And so it's a way of keeping the cell, regenerating itself in a way, keeping its function optimal. Maybe that's the best way to say it. Yeah. And thus, people have looked at autophagy as a key to longevity, that if you can promote autophagy, well, then your cells are going to continue to work better, regenerating themselves in a way. And I'm not saying that they're resurrecting themselves, but just keeping themselves functioning optimally. And then that would then logically lead with greater longevity. Now, in humans, of course, we don't have any evidence to confirm that. But that's a lot of the rationale behind the caloric restriction studies. Caloric restriction promotes longevity, and that's not a sentiment I'm endorsing at all, but that's the general sentiment. Calorie restrict, that promotes longevity, and the intermediate event would be because it's promoting autophagy. At least that'd be part of it. The truth of it is insulin controls autophagy. If insulin goes up, autophagy stops. Because autophagy is wasteful. Insulin wants to store. Autophagy is getting energy. It's catabolic. It's breaking down parts of the cell. Of course, it's in the effort of keeping the cell optimal, but it is still breaking stuff down. It is catabolic, and insulin is anti-catabolic, and it is anabolic. And those aren't the same thing necessarily. Insulin is anti-catabolic in certain instances, like at the muscle. It is anti-catabolic, and yet it is anabolic in other places, like at the adipocyte. So nevertheless, insulin very much controls autophagy. And there are other variables too, but insulin's the elephant in the room. So once again, we can come back to that insulin to glucagon ratio and essentially ask, what keeps the insulin to glucagon ratio in a fasted state. Because if you are fasted, you are activating autophagy. Now, like I said earlier, according to Roger Unger's work from decades ago, and this has changed, of course, because we have higher sensitivity tests to determine insulin to glucagon now. But if I remember correctly, the fasted insulin to glucagon ratio is around 1.5. If you eat a ketogenic diet, your insulin to glucagon ratio is around 2. Okay. If you eat a standard Western American diet, it's about 4. So significantly higher.
Right.
And so I can't say exactly where that cutoff is, but I would say essentially if someone's keeping their insulin at essentially fasting levels, autophagy is running. Whether it's a caloric fast or what I call the nutritional fast, it's still going to be activating autophagy, or it won't be stopping it.
Yeah. But we can't measure autophagy in people, can we?
You cannot. No. So there is, you only have these kind of surrogates, but I would strongly submit the insulin to glucagon ratio is a great surrogate. And maybe to keep it simpler, because as hard as it's hard to get insulin measured, of course, it's even harder to get glucagon measured. Yeah. If your fasting insulin is going to be around 6 and below, I would strongly submit that person has active autophagy.
Yeah, that's really fascinating, because for most people, they're stressing that it has to be a fast, that it's not just a nutritional method of keeping insulin low. So that's a great perspective. And, again, we don't know one way or the other for sure, but it makes a lot of sense to say if insulin is sort of the controller, then as long as you're keeping that at a low enough level, you're triggering autophagy.
Yeah, now one important caveat there, and that says back to protein. There are many people who promote longevity diets, and the whole shtick of the diet is restrict protein.
Restrict protein, right.
And that's because protein is known to activate mTOR, and mTOR is known to inhibit autophagy. And so that's their paradigm. Restrict protein, and so eat these bars, drink this shake, and it's very low protein. But it's high carb. Oh, that's fine, because it's protein that inhibits autophagy.
But what about insulin?
Yeah, there's a wonderful study that looked in muscle cells, and it took what I think may be the most, if not one of the most, mTOR activating amino acids, which is leucine, compared leucine to insulin. And leucine and insulin both increased mTOR at I think the 15-minute mark. Insulin did it higher. So here's insulin, here's leucine. I don't know if this is recorded. People might know, but for people who aren't listening, I'm going to describe it. Yeah. I won't pantomime with my hands. They both went up. Leucine and mTOR exposure at the muscle cells. mTOR went up. At 30 minutes, the leucine treatment down. mTOR is gone.
Really, just 30 minutes?
It was already back down to baseline. Not the insulin. It stayed high, and it went 4 times, I think 3 to 4 times higher mTOR activation, and it was maintained for about 3 times longer than the leucine. And so when the people that are pointing the finger at mTOR and implicating protein as the main mediator, I say that's bonkers.
Yeah.
Don't restrict protein, which we know is necessary. And even we have these same people who are poo-pooing protein, in their own human data, they find, oh yeah, sure, but when you get to 65, then actually if you eat too little protein, you die more. That kind of challenges the whole longevity paradigm, with protein being the villain. To me, if you want to control mTOR because you want to promote autophagy, well then control insulin, and also acknowledge that we need to inhibit autophagy at some points. We can't have autophagy constantly running in, say, our muscles and our bones. Right. If so, they'd be always catabolic.
We'd waste away.
So you have to be able to have these moments of activating mTOR, inhibiting autophagy, promoting anabolic processes. And so even in that sense, insulin is good, but protein is too. We can't. And I'm sure someone listening to me would be thinking, yeah, Ben, I'm not saying protein's bad, even though I'm studying it. Yeah, but the more we try to pin the protein as the culprit, the more we're missing the true villain, and that is insulin or hyperinsulinemia. If someone wants to activate autophagy and inhibit mTOR, scrutinizing insulin will give them a far bigger bang for their buck than scrutinizing protein.
It's fascinating. That's a different perspective than we're hearing commonly right now.
Exactly.
And mostly we're hearing it from the vegan community or the vegetarian community, because they tend to be more anti-protein. But in theory, on the superficial level, it makes sense, protein and mTOR. But as you're saying, insulin is a much bigger player, which brings into this sort of cyclical nature of an occasional 5-day fast where you're limiting protein, but you're also limiting insulin because it's a fast. But you don't want to do that all the time. Obviously, it's very difficult to do and resets your metabolic rate down. So are you a fan of intermittent sort of longer fastings, twice a year, 3 times a year, that kind of thing? Or do you think a steady state of keeping your insulin low is sufficient? You don't really need to do more for longevity, for health?
Yeah. So for me personally, I don't enjoy multi-day fasts. I once tried a 2-day fast and I just did not enjoy it. Now, someone would probably say, oh, Ben, you just needed to give it a few more hours and you'd get into that true kind of long running state. Yeah, but I just enjoy eating.
Yeah.
And I enjoy as a dad in a family, there's only so many days you can sit at the dinner table and watch the family eat while you're talking with them, hoping your kids don't really notice. I mean, and that's something I'm very mindful of. I don't want to eat in a way that my 2 daughters especially, but that maybe sounds bigoted, but even my son would look at me and say, oh, okay, daddy's not eating, so I'm not going to eat. I mean, I'm so worried about eating disorders, partly because I'm a professor on a college campus and eating disorders are so rampant among especially young women at that age. I'm terrified of somehow contributing to someone's eating disorder. So, but nevertheless, I enjoy eating. It's not something I enjoy going without. So for me personally, I'm a huge advocate of time-restricted eating, 18-6 in particular. I will very rarely eat breakfast. I simply just don't enjoy it. And I do my calisthenic body weight type workouts in mid-morning. And if I've eaten, I'm just more sluggish. I can't perform as well. And I just find like I don't need it. I just don't need breakfast. So these multi-day fasts, I think they can absolutely have a place. And I can deeply appreciate those in the low-carb community who are the big advocates of it. There's no question there's an effect there. No question. And I can look at that and nod my head and give them a thumbs up. But I'm not as much a fasting guy. I'm an insulin guy. And I think, okay, the benefit of that, there may be other benefits of the fasting, like just breaking an addiction for food, realizing you don't have to have that when you think you do. But if I'm looking at fasting as a tool to lower and improve the insulin to glucagon ratio, which is in fact kind of how I look at things, I think, yeah, there's a more comfortable way to do that, that is more sustainable.
Yeah, that was a great description, and I love you, the scientist. I mean, you know the science, but also the practicality of it, and it has to fit into life, and there's much more to consider with you as a role model, with you as a father, with you as a teacher, and promoting something that could trigger problems with eating disorders or sort of a body appreciation disorder. Or there's much more to that. So that's pretty fascinating, and there's this whole world of are we promoting disordered eating by promoting a low-carb, quote-unquote, restrictive diet. And there are people on both sides of the spectrum. On the one hand, you're eating all the vegetables, all the meat, all the eggs, all the cheese. How's that restrictive? But on the other hand, in today's society, it's seen as very restrictive. So
it's frustrating. I had in fact, just this semester, not naming names, so I'm not disclosing anything, I had a student who approached me and said, Dr. Bickman, it's uncomfortable for me when you talk about low-carb diets because it triggers my eating disorder. Now, first of all, if I can go on a tangent, I hate that there's been the birth in this generation of the term trigger. You know, for me as a middle-aged guy, no one can trigger me. You know, Brett, you could say whatever you want to me. I'm in charge of myself. You see my point, but I'll stop. So no one's triggering me. I'll pull the trigger myself if I want it. But my frustration with that was when the student, first of all, I was glad the student actually approached me as her professor. I was very gratified and proud of her for doing that. But I was also very frustrated, and I had to take a moment to clarify, and I confirmed, was the student asking me not to show the data? Because that's all I ever do. It is only ever, here's a clinical study, another one, another one, another one. No, she wasn't. It was the way I was talking about it. And I thought, well, how am I talking about it? And I do tend to be a very boisterous, somewhat rambunctious speaker, especially when I'm trying to keep my students engaged for 2 hours. I have a 2-hour lecture period.
It's a long time for college.
Yeah, when you're competing with Instagram and Facebook, when you got to be kind of clever in how you're talking about stuff. And so I did, in fact, very humbly and sincerely scrutinize the way I talk about things and thought, all right, maybe I can be a little more respectful. But on the other hand, and I asked the student this, I said, have you had similar conversations with professors who have been showing data or talking about low-fat diets? Because if you're telling me this, mind you, I was very respectful and polite, But I hated the idea that it was only the professor who was talking about a low-carb diet that was triggering an eating disorder.
Yeah.
And what I liked what you'd said a moment ago, when I show these students the data, what is the common theme of these clinical studies is that it's calorie unrestricted. It's the antithesis of starvation.
Right.
It is don't count your calories, eat as much as you can until you're full, and then you're done.
Right.
It's glorious. It is not calorie counting. And to me, that is the crux of so many genuine eating disorders like anorexia or even bulimia. It is, I can't get that calorie into my system. I need to restrict the energy. So I rage against that idea. And I really hope, in fact, the very students or anyone who's claiming that an advocate of a low-carb diet, and mind you, when I'm in professor mode, I'm not advocating anything. I'm just showing the data.
Show the science.
And I end up getting kind of lumped in as an advocate simply because I'm the only professor who's showing it. And I do find I have to be a little more heavy-handed to make up for all the professors who aren't.
Right. It's true. I mean, even if you are science-minded, which you definitely are, and sticking to the science, you still need a louder voice to overcome the hundreds of other voices that are telling the opposite.
Yep.
Right?
So I kind of get branded a bit of a heretic. But in reality, I'm actually still trying to be quite open-minded to all of it. I'm just the one who's the most open-minded that I've looked at the other side enough to really appreciate it. Yeah. Mind you, there are other, I will say this in defense of my colleagues, there are several other professors who feel the same way I do, many of whom, because they've personally experienced the incredible metabolic benefits of it. These are guys who've lost phenomenal amounts of weight, and they just find they can't help but talk about it because they're so enthusiastic in a way that I'm not even. Like they have a conviction that I don't because they felt it. I never really felt it. I just had the academic conversion.
Right. Yeah, so you're unique in that sense that you had the academic conversion, whereas most people have the personal conversion and then look into the academics secondarily after that.
Yeah, but you can understand. I think you probably had the same kind of growth where it was more of a genuine, show me the numbers and holy smokes, this isn't quite what I thought.
Right. For me, it was more seeing it work in my patients and then looking into the evidence and realizing that it's not as clear-cut as it was being portrayed. And then, like you said, once you open your eyes, you can't go back. I mean,
you can't unsee it.
You can't unsee it. Exactly. Yeah. So one of the other things you've talked about is ketones as a specific marker, as a specific effect in our bodies. And I guess there's a little bit of a debate, which some would say don't matter, and some say scientifically absolutely matters. Is it just lowering the carbohydrates that give a lot of the benefits of a low-carb diet, or is it actually the ketones themselves having an active role in our body and playing a beneficial role?
Yep.
So
Great question.
Tell us about the science behind that.
What a great question. And I feel qualified to answer it because of my growth. As I sort of told my academic background at the beginning, I really have come into this conversation academically, professionally, through the lens of how can someone best control their insulin. And that's what got me looking into and scrutinizing low-carb diets as a legitimate intervention in what I still now consider, or what I now consider to be the most effective way, calorie for calorie, to control insulin, lower the carbohydrate. And it is so rational, right? And so my perspective, my paradigm had been, how can insulin stay as low as possible? And then I was seeing, while I was starting to look through the human clinical data, studies that would refer to ketogenic diets. And I, of course, knew I'd had nutritional biochemistry. I knew what ketones were. But because I'd had nutritional biochemistry as a student, I also didn't appreciate them because they are not talked about in any way except negative. Right. In classic academic settings, ketones are more than just quote-unquote metabolic garbage. They're looked at overtly harmful molecules that should be avoided at all costs. Right. I mean, it is overwhelmingly a negative a connotation to the ketones.
Right. We're only taught about ketoacidosis
as a
life-threatening condition.
That's exactly right.
And not about anything beneficial.
Nothing else.
Yeah.
And what a tragedy. It truly, and I mean it, what a tragedy, especially when we look at it in the context of diseases of Alzheimer's or overt or genuine instances of glucose hypometabolism, although this is a tangent. But when we know that in Alzheimer's disease, the brain cannot use glucose as well. We are just about to publish a paper looking at gene expressions from different sections of the brains, human brains postmortem, looking at glycolysis genes in brains of normal brains versus brains with dementia versus ketolysis, the ability of the brain to use ketones.
Really?
Whether the brain, dementia or not, ketolysis gene expression, perfectly normal. Glycolysis gene expression, not at all.
Interesting.
And I'm talking about p-values of 10 to the negative 9. I mean, these are massively beyond any hint of coincidence.
Yeah.
The brains, dementia brains have a compromised ability to use glucose. And we know this in human studies looking at glucose tracking to the brain, radio imaging. And sure enough, if the brain can't use glucose, there's only one other fuel. That's the ketone. But anyway, our fear of ketones means people don't want them at all. But back to my story, I would see in these low-carb studies some calling it ketogenic. And I would kind of look at that with a little bit of a grimace and think, well, ketones are bad, so I don't want to study that, or I don't want to look at that study. But more and more realizing or appreciating insulin's firm control over biochemistry, that ketogenesis is an indicator of controlled insulin. And that was my initial appreciation. I thought, all right, if someone's in ketosis, it simply means their insulin is low, and that's a good thing. So even then, firstly, I was looking at ketones as no more than an inverse indicator of what insulin was, because if insulin's low, ketones are elevated. That was it for a while. And then it was starting to see more and more of these studies being published looking at how ketones improve contractility of the heart. For example, so greater ATP production, so the actual molecule that can allow the muscles to contract, more ATP production per oxygen consumed. You think about an ischemic, hypoxic heart, there's less oxygen and it can maintain ATP production.
Right.
So the ketones improving heart contractility, ketones reducing oxidative stress in neurons. And I was seeing this and thought, you know what, I want to step into that. And the greatest beauty of being a scientist is freedom. If I have a question, I can ask it. And then if I see, do I have the tools to answer that question? So we started asking some of these questions. And to this point, we've published the one paper looking at how ketones improve or reduce the oxidative stress from muscle cells and enhance muscle cell survivability. So they're more kind of rigorous, if you will, more resistant to insults.
Yeah.
And so that was a paper we published last year. We are finally wrapping up our paper looking at the way ketones affect mitochondrial function in fat cells, and that's kind of the browning of the fat, making
the fat more metabolically active.
That's it.
Yeah.
Yep, by several times, by multiples. We have another study looking at how ketones affect memory and learning in brain, and with some very clever brain studies we're doing. So anyway, to your point, or to your question rather, I think the vast majority of the metabolic benefit that comes from a low-carb diet is that insulin is controlled. I really do. Now, it might just be that I'm the man with the hammer and insulin's the nail and I see it everywhere, but even still, I maintain that lowering insulin is the main metabolic benefit. And then the ketones provide, that's the 80% of the benefit of low carb is from insulin control.
Right.
And the ketones provide that next 20%. Now, mind you, the more I'm learning about different molecules you're eating from high starch foods, there could be other factors, oxalates, for example, and that's stuff I don't really know enough about, but that might be a sprinkling in there. But to me, it is mostly controlling insulin.
Yeah, and it's a very pertinent question, because an issue that comes up all the time is, do I need to be in ketosis? When is just low carb good enough, and when do I need to be in ketosis? And if the ketones have beneficial properties on their own, that's more of a vote to go into ketosis. But like you said, it's sort of the 80-20 rule, right? If you're going to get the majority of the benefits by going low carb for most people, with a little bit added benefit by going into ketosis. Now,
I would say that's true. Yeah, unless there's an overt like pathology, like dementia, or migraines,
or
ketones,
if you're already diabetic, or if you need more rapid weight loss, then the ketosis will probably be beneficial or faster. But for a lot of the sort of average people, then low carb is good enough with a little added extra if you're in ketosis.
Yeah, I think so. That's a good way to say it.
Yeah, I think that's an interesting point. All right. Well, we've talked about a lot of different subjects, a lot of science, but you've already referred to sort of your role as a family man, your role as a father, and that's sort of your primary job, your primary role, which is can be difficult when you talk about food as a family, as a role model, as, how do you feed your kids in today's society? And I know a lot of our listeners have kids and probably wrestle with this. So tell us some of the strategies and things you use with your kids to help them learn about health, to help them learn about nutrition, and to be that role model for them.
Yeah. In fact, Brett, thanks for bringing it up. Without a doubt, when I'm lying in my bed at night, I'm not stewing over my decisions I made at work. That's such a small part of what I'm thinking about and what I'm not worried about, but just thinking about. It's family. I think about my relationship with my wife, my relationship with my children. That is priority number one. I'm aware enough to know that at the end of my life, I'm not going to regret if I wasn't in the lab enough. That's not going to be my regret. So for me, the low-hanging fruit in my wanting to impress upon my children the importance of what they eat, it is that I talk about fat and protein as wonderful things. And I don't really give them opportunities in the house to get away from that. We don't have cereal. They never eat cereal for breakfast, ever. We don't have bread. We don't have sandwiches for lunch. We don't have crackers. That's just not part of the snacking system. It is little pepperonis. It is cheese sticks. It's a vegetable platter with some non-seed oil ranch dip, where we make a ranch dip out of just a ranch seasoning in whole-fat Greek yogurt, for example, or sour cream. I think that's maybe what I use. What my wife does that. Anyway, I will tell them when they're depending on whatever kind of food they want. I'll say, let's try to get. How can we have a little more fat here? How can we have a little more protein? I want my kids someday to go away to college, and when they're living with their roommates, they'll open the fridge and they'll see skim milk, and they'll say, "What's skim milk?" Or they'll see low-fat-free yogurt. Fat-free yogurt.
Why would you want to take the fat out of the yogurt?
I want them to be so stumped and befuddled that there's a significant part of the people who are afraid of fat. I want my kids to know fat is their best friend.
Right.
And protein is a close second. Or, maybe it goes hand in hand. But essentially, my wife and I have been able to, mind you, it's still such a battle, right?
Right.
The kids want junk food.
And they're going to get it at their friend's house.
They're going to get it.
They might get it at grandma's house or at the uncle's house.
That's exactly right. You just can't get away from it. And so they're going to put up fights. I don't want anyone to hear me and think that Bickman's kids skip down the stairs in the morning ready for bacon and eggs. No, it doesn't matter. I've been feeding them bacon and eggs for years. They'll eat all the bacon, and they'll just pick at their scrambled eggs. And I'm looking at them thinking, eat your bloody eggs. So that's the reality. It's far closer to reality.
Yeah.
It's not like my kids just will delightedly go grab a cheese stick. No. Maybe one of them will, and another one will complain about it, and they'll say, "Well, I want this," and I'll say, well, "We just don't have that. We don't eat that."
Right.
And maybe someday it'll backfire. Maybe they'll someday get out of the house, but they also know that they're healthy and they're fit kids. They know that. And so I'd like to think, and they know that mom and dad are healthy and fit, and they know that other mom and dads aren't.
Right. I think that's an important point, and it's hard to bring up in a sort of politically correct way to say, look at us and look at some of your friends' parents and compare us. And it's a hard thing to say, but probably an important lesson. And, when you travel, when you're in the airports and you see sort of like a slice of humanity and how heavy everybody is, I'll never forget when my son, I think he was maybe 5 at the time, he's like, is that person really sick? Because he talked about a very heavy, overweight person that he just, I guess, doesn't experience all that much in his day-to-day life. And he says, is that person really sick? Why is he so big? And then it's a hard conversation to have with a 5-year-old, but I was sort of pleased that they understood that that's not right. And there's a reason behind that. And sort of that's part of the education process.
It's a delicate conversation. Yeah. And for me, I try to focus on the positive, which is, hey, like I'll joke with my son and my daughters too. I want them to be as strong as possible. I'll say, look at daddy's arm when I flex my muscle. See, it looks like the egg. See, this egg is helping daddy be strong. Yeah. You want to be strong. And they all, they want to show off their muscles or whatever. Right. And I'm a terrible example, of course. I'm a pretty teeny guy, but I just want them to focus on the positives. I don't want to scare them into eating, you eat this way, you're going to look like that person. But it's just rather, you've been blessed with a healthy, strong body. Let's keep it that way. Yeah. This is why I want a healthy, strong body. For me, mommy wants a healthy, strong body. We're trying to do this by eating these kinds of things. And so they do know it. As much as they might fuss about it, they'll want ice cream. If I let them eat ice cream, they'd eat it all the time, of course. They're not those kinds of kids that are going to be offered ice cream and say, no way. They'd eat it. But I want them to know that's on one side of this food balance. And when we indulge in it, it is a treat and we enjoy it. And then we know, however, that it can't be maintained and it can't be every day.
Right. Yeah, very good point. Very good perspective. So tell us what a day in the life of Ben Bikman looks like.
Yeah. So I'll usually wake up. Well, lately I'm working on revisions for my book, which that'll be next year. But it is, in fact, it's that whole kind of Plagues of Prosperity story.
Yeah.
Which is we have all these fears of chronic diseases and we're treating them in all these distinct ways. There's another way of looking at it, which is address one common core, and now we can start addressing pretty much everything else. So I'll wake up around 5:30, maybe 5, and then work on the book for a bit. Then the kids start to wake up around 6:30. We're very strict with bedtime. The 6-year-old goes to bed at 6:30. The 8-year-old goes to bed at 7:30. The 12-year-old goes to bed at 8:30.
Oh, wow.
It is written in stone. Now, mind you, they're not in their bed and lights out, but that's when they're in their room. They potty, brush teeth, wash their hands. I mean, there's that kind of rigmarole. We'll do a little prayer and then we'll read or whatever.
Yeah.
And I'll lay by them and hold their hand for a long time. So it takes a while for them to actually fall asleep. But even still, they do and they're out. So they'll start waking up about 6:30. I make breakfast. I'm in charge of breakfast. And we kind of rotate. It's bacon and eggs. It'll be some little egg muffins, or it'll be low-carb waffles made out of just different, kind of whey and some different types of fats.
But you've mentioned you do like an 18-6, so you don't partake in the breakfast.
That's right, yeah. So what I may sometimes do, depending on what I've made for breakfast, I'll bag it up and take it to my office. So, but it just depends. I don't personally like the low-carb waffles that I make. My kids do, so I make it for them. And that would be something I don't eat, and I don't bring anything with me. And so if I'm going to plan lunch for the day, I'll make I'll either bring lunch, some cheese sticks, some meat, some hard-boiled eggs, which are a staple for me, or I'll make a shake. And I love putting eggs in just raw, Rocky style kind of shakes. And I'll use actually a shake that I'm involved in making called Best Fats. I'll put that in there with some eggs. And then that's my kind of, that'll be lunch. Keep it in the fridge. And then dinner is dinner. Whatever the family's having. Mind you, my family being what it is, it's never usually high carb. It might be moderate, but usually it's pretty low. Or there's an easy way to make it low carb. But I'm not going to be too disruptive to the family. If we're getting pizza, the kids are going to eat it, and I'm fine with that. I'll usually eat the toppings, and the kids know it, and they'll tease daddy about it. But that's an easy enough one to do that it's not too disruptive. I'll usually do my workout around mid-morning. Depending on the time of year and the semester, I'll teach in the Tuesday, Thursday afternoons. But then most of the time is writing, and then a little bit of time in the lab now with my students. I have enough graduate students that they keep the lab running independently of me, and then I'm working on a grant or a paper. Usually one of those two things.
Yeah. All right. Very interesting. Good slice of life from Ben
Pretty
Bikman.
underwhelming.
Yeah. But, I really appreciate that you're out there, that you are the scientist asking the questions, investigating to try and find these answers, and doing it from a science standpoint, that you're not going to be the zealot promoting things above and beyond what the science says. You're always going to come back to the science, and it makes you incredibly trustworthy. We know when you're saying something, it's based in science, it's based in academics, and if we find a way to apply it to our lives, then it should work and it should make sense.
Right. Good. Well said.
It's great perspective. Well, thank you so much for joining us. And where can people find you to learn more about you?
Right. Yeah. Thanks, Brett. Thanks for the invitation, first of all. Yeah. I like I said, about a few years ago, I became active on social media. I detest self-promotion blatantly, so it's never pictures of me. I don't like that for me personally. Yeah. I try to just share research, whether it's my own research from my lab or latest published research or even old research findings. I'm mostly busy on Instagram and Twitter, and my handle there is Ben Bikman, PhD. Mm-hmm. And then not so much on Facebook, so that Facebook's just a little too overwhelming. Yeah. But that's I consult with a supplement company at Unicity, which is great. And then I also have my Insulin IQ group.
Great. All right. Well, we look forward to seeing more research out of your lab and all your postdocs working with you. So great.
Thanks, Brett.
Thank you.